Section 20.2. This is starting to get into other ways to tell if a triangle is congruent to another triangle beyond just the corresponding parts being congruent. That is, all the sides being the same and all the angles being the same. There are some rules with triangles that if you have particular parts that are congruent, you can also prove they're congruent without knowing the measures of the other parts. So one of these ways is called the angle-side-angle triangle congruence theorem. ASA stands for angle side angle. And what that means is that if two triangles and the included, or two angles and the included side, two angles and the included side of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are also congruent. So in this one, right, we've got essentially this symbol here means that angle D and angle A is congruent to angle D. And this double line symbol there, right, there's the double line symbol there. That means angle C is congruent to angle F. And then this single hash mark through the line means that side AC is congruent to side DF. And like the name says, here's an angle, here's its included side, and there's another angle that are congruent to each other, otherwise known as angle-side-angle congruence theorem. So let's take a look at an example. You've got, again, triangle JKL, and you've also got triangle MNP. And again, I just label them with numbers because my brain, it's easier to work that way than with the letters. JKL. And now it's really easy to see, right? J corresponds with M, K corresponds with N, P corresponds with L. So let's take a look. Do we have essentially an angle, a side, and an angle? So here's an angle, 116. That corresponds with this angle right here. So this must be 116 if that's the case. How would I know if that's 116 though? The answer to that question is 180, right, the total sum of the interior angles of a triangle, minus 33 and minus 31. What does that equal? If that's equal to 116, then we know that angle K and angle M are congruent. So I'm just going to type that in my calculator. 180 minus 33 minus 31. It is in fact 116 degrees. So that's definitely the angle, but I'm not sure it's the angle I'm looking for. So let's take a look at this other one. Then if this is 31 and 116, this one's got to be 33. Right, because 33 plus 31 plus 116 equals 180. So it does appear that these correspond. And what are the angles we're going to use? So we've got basically angle J which is 31 degrees, is the same as angle M. So angle J and angle M are congruent. Now their side, there's this side right here, and that side right there. Are these corresponding sides? 1 and 3, 1 and 3, they are. So basically, right, what do they measure? They both measure the same thing, don't they? 6.5. So we certainly have a side that's congruent to another side. We have JI is congruent to MP. And last, the angle. Right, we have angle I, which we've determined to be 33 degrees. Is it the same as angle P? It is. So here we have our angle side. Angle condition has been met. And since essentially we've met the condition, these triangles are going to be congruent. So since, angle J is congruent to angle M, JI is congruent to MP, and angle I is congruent to angle P, then triangle JKL is congruent to triangle MNP by the angle side angle congruence theorem. And right, this is just a lot of ways similar to a legal argument. We're trying to prove a case for congruence, and as evidence, we've cited these three things, and these three things happen to meet the conditions of the angle side angle congruence theorem. So we have now proven our case. Now let's take a look at this next example. So first off, we're probably going to want to figure out all the angles that are in both triangles. Now we know each triangle adds up to 180. So that angle right there is going to be equal to 180 minus 31 minus 110. So first things first, 180 minus 31 minus 110. So this angle K here is 39 degrees. And that angle right there is going to be equal to 180 minus the other angles, minus 38 and minus 31. So 180 minus 38 minus 31. So this angle is 111. And now we're going to try to figure out, well, do we have any of the conditions for the angle side angle theorem? Hopefully it's obvious to you that the corresponding parts are going to be different because the angles are different, right? We've got one congruent angle, right? Angle J is going to be congruent to angle M. That's one condition, but if we use this side, right, that's actually a second condition. This side and that side, we have two sides that are the same, at least if they correspond. Let's JKL 1, 2, 3, and MNP 1, 2, 3. So let's see if these correspond. They do. So we have a second condition. JL is congruent to MP And now that we've done that, well, what about this last angle? 110 and 111. Talk about angle L and angle P. These are not congruent, right? They are different measures. So you have basically angle, side, and that's it. You don't have the other angle. So since the condition is not met, let's say since essentially angle L is not the same as angle P, triangle JKL and triangle MNP is not congruent. Right? This just means not congruent. And it would help if I could spell correctly. Not congruent to the other triangle, right? Because you need to satisfy all three conditions, right? This might be considered a tri-conditional statement. You satisfied condition 1, satisfy condition 2, but condition 3 not satisfied. So you have not proven the case that these two triangles are congruent. And you can't prove it because they are different. The condition is not met. Okay, so now let's determine whether the angles are congruent and explain your reasoning. So you've got this triangle here, and let's try to see if we can figure it out. We know essentially angle B and angle C are the same. So angle B is congruent to angle C. And then there's that line mark between the two lines. So we know that BD is congruent to CD. And that's met. And what about this one, angle D? Angle D. Now, hopefully remember that little square there, that box, if you will, means that this is a right angle. And right angles measure 90 degrees. Now, by the linear pair theorem, right, if I have this, and this is 90, this is going to be 180 minus 90. So what's 180 minus 90? It is 90 as well, right? Here's 90, and there's 90. So then I really shouldn't say angle D, right, even though it's right there in the middle, because that could represent either side. I should be more specific. I'm talking about angle ADC, right here, ADC, that's going to be congruent to angle ADB, which is right here, right? So then the question is, well, have you met your conditions for angle side angle congruence? Well, here's an angle, that's its included side, and that's an angle. So condition 1's met, condition 2 is met, condition 3 is met. So these two triangles, essentially triangle ABD is congruent to triangle ACD. Why? Because right, angle side angle congruence theorem. So there's that one. Now let's take a look at this other example, and then I think from here I'll just keep going. So if we got to find all the angle measures, right? We know every triangle adds up to 180, the inside angles. So that angle right there is going to be 180 minus 72 minus 38. So 180 minus 72 minus 38 is 70 degrees. And this angle here is going to be 180 minus 67 minus 38. So 180 minus 67 minus 38. That angle there is 75 degrees. So it should be become sort of obvious at this moment. I think we have the conditions. We do not have the conditions to make congruent triangles. We know that angle Q is congruent to angle T. And beyond that, everything else is different, right? Other than, these sides, we know QR is congruent to TU, but we don't have a third angle. So we have an angle, a side, but we do not have the third angle. So therefore, it's the symbol. Therefore, triangle PQR is not congruent to triangle STU. Right? Condition 1's met, condition 2's met, condition 3 not met. And this last example, triangle QPR. I'm just going to do 1, 2, 3, and then triangle SPR, 1, 2, 3. And now we can tell our corresponding parts. We're trying to find, well, what values would the variables need to be for these things to be congruent? So first off, right, this is the side. This is the side they're using. They're using side PR. And we know PR is congruent to PR, right? It's the same side, so of course it's congruent to itself. And but then they're using these particular angles, and so you would need to know that essentially this is a condition that's been met, but you would need to know that angle QPR is the same as SPR. So if you knew that, these two things would have to be, we have to find the measure of x to find out what that angle measure would be. So you're going to have 2x plus 7 would have to be equal to x plus 21, right? This angle would have to be equal to that angle. So set them equal to each other and then solve for x. Subtract x from both sides. Subtract 7 from both sides. You're going to get x is equal to 21 minus 7 is 14. So if x is 14, then these angles both measure, well, 2 times 14 is 28. 28 plus 7 35 degrees. And 14 plus 21, also 35 degrees. So now that condition will be met. And this last one, we have to set these two. We would need angle QRP to be congruent to angle SRP. So 8x minus 4 would have to be equal to, or I should say 8y. Let me erase that. 8y minus 4 would have to be equal to 4y plus 28. So subtract 4y from both sides, and then add 4 to both sides. You're going to get 4y is equal to 28 plus 4, which is 32. And 4 times what is 32? That what is 8. So y is equal to 8. So then this angle measure is 8 times 8, right? 8 times 8 minus 4, which is 60 degrees. Or 4 times 8, which is 32, plus 28, also 60 degrees. So this is how to solve this type of situation with angle, side angle, and solving for the variable.